transformations we'll be applying to our parent functions. And what we're going to be graphing is called the child function. So it kind of makes sense, right? So from the parent comes a child, same thing applies here. So in order to graph something like this, we first have to use our parent to get that portion when it comes to it. Okay. So let's just start off figuring out what is a vertical shift. How do we know what's going up, down, left, and right, or diagonal when it comes to it? So what we're going to do is going to graph both of them individually using t-charts and see what's actually happening here. So when it comes to the parent function, so right, this is our parent function because that's our basic square root function, like this one here. So we know it's going to look like that. So let's graph it a little bit more precise. So let's go 2, 0, 1, and 4. Let's pick those three numbers for x values. And if we plug it in, right, the square root of 0 is just 0. Square root of 1 is just 1. And the square root of 4 is just going to be 2. Okay. So let's just graph this real quick. So it's just going to be here, 0, 0, 1, 1, and then 4, 2. So again, just by knowing the graph, we know it's going to look like that, right? Now we just have a little bit more precise way. Okay. Now in the same portion, let's also graph this one here. Again, just using a little t-chart. Throw those out. And if you want, I can use the same one. So we'll say 0, 1, and 4. Okay. So now if I plug in 0, that gives me 0 plus 3. So that's going to be just 3. Plug in 1. Again, square root of 1 is just 1. Plus 3 gives you 4. And then this we got to be careful of because we want the square root of 2. Square root of 4 plus 3. So square root of 4 is going to be 2. So we add that at the end. That's going to give me 5 there. Okay. So now let's just graph this as well. So first point 0, 3, 1, 4, and then 4, 5. So again, it looks like that. Okay. So the question becomes, what happened, right? And it looks like just everything shifted up, right? That's all we did, just shift everything up a couple meters. Well, the question is, how much do we shift up? Well, if we start from our center, right, this is our center point, how much do we go up here? We go 1, 2, 3. Well, look at that. Notice the only difference between this one and this one is this entire column, the y's, was just shifted up by just adding 3. Okay. So that's just precisely what's always going to happen if we have a value on the outside. Okay. And this value is so special, we call it a very special name called k, the value of k. Okay. And what this value tells me is if I'm going up or down just on the y scale. So again, it just tells me it's going up or down depending, again, on the actual number. So fun thing is, if we would do the square root of x minus 3, this would just be shifted down here. So here, there, and there. So it would look like that. So again, it would just be shifted down by 3 units if it was a minus 3 itself. So therefore, we get a very special rule here. Okay. So we have a value of k where we have the situation as this, right? So there's a plus k there. Therefore, we shift everything up by k units. However, if we have a negative k value, so like minus 3, we shift everything downwards by k units. Okay. So, any questions on this concept right here? Everybody comfortable? Okay. So, okay. So before we get any further, there's something I do want to say, right? Again, only the y values are being affected, right? The x's are exactly the same. So there's a slight little hint or little trick when it comes to graphing is that only the y values are changing with k. So again, that only depends if we have a k. So put that in the back seat. We'll talk about this in a little bit. But now what we know, what if this number is inside instead? So for example, something like this. And this is what's called a horizontal shift, which you probably guys are going to think of already since we had vertical. Therefore, we're going to go left and right, right? When it comes to it. But again, just in case we're not sure, let's do this again. So again, we're just going to graph each one individually and figure out what's happening. So again, this is our parent function. So this is our basic parabola, right? It's going to look like this. And same thing, I'll pick a couple numbers. So let's say -1, 0, and 1. Just get a little glimpse of the function. And now we plug it in. So -1 squared ends up being +1, right? -1 times -1 gives you +1. 0 squared gives you 0. And then 1 squared gives you 1 back. Right? So if we graph this, just like we did the other one, so -1, 1, 0, 0, and then 1, 1. So just like yesterday, right, it looks just a nice U shape. And I'll do the same thing over here. All right, so let's see. Let's pick up numbers. Not too much. Why don't we use 1, 2, and 3? When they're not too big of a numbers. Again, right, you could pick any ones you want, but I didn't want to be off the chart. So we'll just pick little small numbers there. Okay. All right, so this one got to work a little bit, right? So if we plug in 1, maybe 1 minus 2 is -1. And when you square it, it ends up being +1 again. Okay, so we plug in 2. 2 minus 2 is 0. And then 0 squared is just going to be 0. So that's interesting. It's kind of looking like the framework. So what do you think this one's going to be? 3 minus 2 is 1. Square it also gives you 1 back. So now this time the y's were the same and only the x changes, right? But again, let's just draw this out so we can see what's happening. So first point is 1, 1. So they share that point in common. 2, 0. And then 3, 1. So like that. Right? So this is what's called a horizontal shift because we're just shifting it left and right this time. So this point just shifted this way. Right? All of these ones just shifted that way. Okay? Now, this is a very interesting concept, right? So unlike the other one where the k value tells you going up or down, right? In this case, if it's +3, we shift up. If it's minus, we shift down. Notice, however, this one. This was a -2, but we went to the right 2. So it's a very interesting way. Why didn't we go negative? Well, that's the only precursor you got to be very careful of. Is the rule actually applies is whatever the sign is, the h value, which is what we call the inside portion, is always the opposite sign you actually see. And that's a very trick question when it comes to it. Okay. So for example, here, our h value is actually +2 because we're shifting 2 positively to the right. If, for example, we had this instead, therefore, our h value for here would be -3, which means we're shifting 3 units to the left-hand side. So when it comes to the h value, so the value inside the parenthesis, inside the radical, inside the absolute value, so essentially that portion, it's always the opposite sign you actually see. So it's a little tricky because it's not as straightforward as the k value itself. Okay. So again, I just give you guys a brief cursor, right? So if I have +h, you're technically moving to the left because it's minus. If you have minus h, you're moving to the right because it's a positive h. Okay? So that's what you got to be very careful when it comes to it. Okay? And the last thing is, right, notice when we go from here to here, so from a parent to child function, y stay the same, now x has changed. And now notice, right, how do we go from there? We actually added 2 to get to those new ones, right? -1 plus 2, 1. 0 plus 2, 2. 1 plus 2, 3. So when it comes to this one, only the x values change. Which means each letter represents what changes from which one. So h changes the y values, and h changes the x values. Okay. So therefore, we kind of have a relationship or something called a translation. What a translation basically, in layman's terms says there's a way to go from one to the other using some function, right? And how we're going to use that transformation is something called this and that. It's going to be x plus h and y plus k. Okay? Now, how this is going to go back is actually not as bad you may think. It's pretty doable. The first thing we're going to do is make a little t-chart of our parent function. And we'll pick some numbers. You could put, the usual ones are always going to be this, and you can always use those if you want, right? And then depending on what we get for the y values itself. Okay? And then we're going to make a line just like this. And then we're going to make a new t-chart, just like we did here. Okay? And this new t-chart is going to be the child function. So essentially what we want to graph, right? So essentially we want to graph this. That's going to be our child function. How we're going to go from here to here is we're always going to be adding h to the x's, or subtracting, depending on what it is. That's a bad one. There we go. And we're always going to be adding k to the y values. Okay? And it's not as difficult as you may think when it comes to it. So let's just do examples so you can see how that's going to go about. And essentially is for every column, you're going to be adding h. For the y's, you add k. And that's pretty much always guaranteed when it comes to it. It's a nice slick way of it bypassing what the transformations are and just going straight to the answer itself. So let me give you an example before I ask any questions, so you guys can fully understand this process here. Okay. So let's just do this example so you guys can see how would that work out. Write that there. Okay. So this is our child function, right? We want to graph the absolute value of x minus 3 and then plus 2. So the first thing we want to do is write our parent function. So remember, parent function is where does it come from? The bare basics. And it's just the absolute value of x, right? That's what comes into play, right? It's just a curve. So the parent function is the absolute value of x. Right, so in other words, with no numbers attached, right? Like this one, the parent function is just the parabola, x squared, right? Because we just dock it off, we just get x squared. Okay, so we're going to graph this one, again, just using our simple t-chart. And again, you can just use the same ones if you want over and over again. It really doesn't matter. So plug it in. Absolute value of -1 is 1. That's 0, and that's also 1, right? Very similar to the problem. Okay, now before we go any further, so we actually graph our child function, we want to write down two things. What is our h, and what is our k in this situation? Okay. So let's just do the easy one first. In the chat, or if you guys can say it out, what is the k value in this situation? So what's our k value? Two, good. So it's 2, good job, nice, okay. So now, little tricky one, right? What is our h value? Remember our rule when it came to the h. There they go, +3, right? Opposite side. So instead of negative, it is good, +3. Okay. So now, how we're going to do this quick little transformation is for every x value we have, we're going to be adding 3 to it, according to our rule, right? It's the h plus the x. And for every y value, we're going to be adding 2 to it, because that is our k value. Let me quickly focus this. Okay. Now, how you can do this process is we're going to do column by column. We're not going to go cross, cross, cross. We're going to go down first. All right. Remember, this is just a function. You're literally just plugging them in where they're supposed to go. -1 plus 3 is +2. 0 plus 3 is 3. 1 plus 3 is 4. Okay, you're done. Done with the top. Now we're doing the same thing now for the y's. But instead, we're going to plug it in here, right? Because it says y2, right? Y plus 2. So 1 plus 2 is 3. 0 plus 2 is 2. And then finally, 1 plus 2 is 3. So this represents this graph there. Okay, so before I go any further, any questions on what we just did? So everybody good? Okay, all right. So now all we have to do is graph this and we are done. So remember, these are points. So +2 up 3. Up 3. +3 up 2. +4 up 3. And we know it's a absolute value, so we know it looks like a V. So just connect dots, make your V, and you are done. So that's how we're going to graph all of these transformations using our parent function and just doing our quick little transformation and just plot those 3 points and make it look like it's supposed to go at the end. Okay. So let's try another one. Or do we have another one? Or not yet. I want to do all of them at the same time. So before I give you another example, I want to go over 2 more rules and then we'll do plenty of examples afterwards so you guys can see all the different situations happening here. Okay. Okay. So vertical stretch and horizontal stretches are not as common, but I do want to talk about them because they do tweak it depending on what you have, especially. Okay. So a vertical stretch. So a vertical stretch looks something like this, where you have a number outside of the absolute value, the parenthesis, the square root. So it's a number on the outside. Okay. So if you have this situation happening, it's if A is a fraction, so like 2/3, any fraction, less than 1, it's something called a compression. If it's greater than 1, so like this number is right, 3 is greater than 1, it's called a stretch. You're stretching the graph accordingly. Okay. This, however, is very special because in general, all the y coordinates will be multiplied by this single a value here. Okay. And again, I'm going to give an example of how that's going to come into play in a little bit. Okay. But the key thing is, again, the y values are being affected by that outside number. Okay. On the contrary, horizontal stretches and compressions are the opposite. So that's if a number is on the inside. So for example, like that. So the 2 is being multiplied by the x, right? So we have a number on the inside. Well, we just do this, make it easier. There's a number being multiplied to the x, right? So that's what we mean by there's a on the inside of the function. Okay. Now, when this happens, Again, if a is greater than 1, it's called a compression, so they just swap places, basically. Again, you don't have to memorize what is a compression stretch, but it's good to know if you're wondering what happens when it comes to it. Okay? But again, the biggest thing is, unlike vertical, where it changes the y values, when it comes to horizontal stretches, when there's numbers on the inside, it affects the x coordinates. Now, this is the most important thing because it's not, again, weird at all. Okay, so when it came to vertical stretches, we multiplied the coordinate by y, and this time we multiply by 1 over that actual number. Again, these are the most difficult to do because they're kind of funky when it comes to it. You won't see too much of it, but it's again always good to know. And I'll give you an example of each one so you can see how each one's going to be affected respectively. Okay, but again, I just want to give you guys rules. And again, it's much easier to show you how things are going to happening, things like that. Okay. So now we have example after example after example. So best part, right? So you guys can see what's actually happening each individual case itself. Okay. So we want to graph our child function of the square root of x minus 2 plus 3. Okay. So first off, we want to find our parent function. So our parent function, again, it's going to be one of those 5, and it has to look just like this. So there's no other one that looks like it, right? It has to be the square root of x. So we're just going to make a little t-chart. Notice I can't plug in -1 because it doesn't exist, so I have to start at 0. I don't know what square root of 2 is, so I know 4, so we'll just do that, make it easier. So square root of 0 is just 0, square root of 1 is just 1, and the square root of 4 is just 2, right? We did it earlier. All right, so now we want to identify a couple things. So now we have this new a value, so I also want to identify that as well. Okay. Remember, the a value is usually the one number in the front or right next to the x. And most cases, they're going to be the same number. So hint, hint here, the number in front of this is just a 1. Same thing in front of the x's, so a is 1. So nothing's going to be changed when it comes to it. When it comes to h, what is our h value here? What do you guys think? Yep, 2. Perfect. Nice job. Positive 2. And the k value is nice. It's just going to be 3, right? Just the number in front. Okay. All right. So now if we do this transformation to our new x, y, so it's going to be x plus the k value, or the h value, so it's going to be plus 2, and y plus the k value, which is 3. Okay. And again, column by column, never go across, right? So if I just start here, right, 0 plus 2 is 2. Okay. 1 plus 2 is 3. And then 4 plus 2 gives you 6. And there you go. You're done with the x's. Now we do the same thing for the y's, but now we use the bottom, right? Because this is y plus 3, right? So just these. So 0 plus 3, 1 plus 3 gives you 4, and then 2 plus 3 gives you 5. And again, we graph this, and we're actually done, because that's the graph of that portion there. So 2 up 3, 3, 4, and 6, 5. And again, no, remember, I don't do this because the square root function should look like this. So I know I should not be going down, right? It stops at that point and just goes that way. So it should follow that part of it. Right? And there we go. There is our graph. Questions at all? No questions? that case, let's try some more examples then.